Hello everybody, this is Celesta Matthews and today we are going to see two programs, one using pipes, the named pipe, and the second one using the unnamed pipe. So we'll see the named pipe first. We'll open the file VIE91 underscore reader.c. Here is the file. So in the second terminal, I'll open the writer file. Here it is. So what basically a named pipe is that, first of all, the named pipe will have an entry in the directory. So if it has an entry in the directory, it will be having the inode number and many such stuff. And other than that, a pipe can exist if a reader process or writer process is not accessing it. The same thing is not true in the case of an unnamed pipe. And these pipes are used for communication between two unrelated processes. So you can see that we have two different programs over here, and we will be communicating between both of these values, or we will be transferring data between both of these values. So first of all, if we have a pipe, we need to write something into that pipe. Only then some other process can come and read it from that pipe. So we'll see the writer process first. Inside the writer process, I have int fd. Now mkfifo is the system call that is used to create a named pipe. So the name of the pipe will be my file, and 0644 is the access permission for that particular pipe. Now we open that pipe. As we open the file, it's very similar to that. We say open my file, o underscore write only. That means we're opening it in write mode. Now we have a character of 100 bytes. After that, we ask the user to enter some data. Now, once the user does that, we calculate the length of that string that the user has entered and save it into a length variable. After that, using the write system call, we'll write that data into the pipe. So what we do is that we pass the fd, that is the file descriptor which is returned by the open system call. C will be the buffer or some variable where the string that the user entered has been saved, and length will be how much bytes you have to write into that pipe. After that, we close it. For the reader process, now once the writing is complete, the reader can read the data from there. So the pipe was created by the writer process. So in the reader process, we assume that the pipe already exists. Inside that, we have to create a buffer of size max path, that can be any size. I have used 1024 over here. After that, as we did in the writer process, we open that file. It returns as we open that pipe. It returns as a file descriptor, and then we read from that pipe in a similar way as we read from the file. Once that's done, we print that particular value. Now we have to count how many vowels are there inside that string. So we say while I less than strlen at buff, and inside char c we store the character that we are reading at present, and after that what we do is we print that character. So actually I don't require that, but still we'll have it for reference, and we compare it with all the vowels over here. If it matches any of these, then the count value will be increased, and the I value is increased continuously. Now we will go ahead and execute this file. So this was the reader process. I have to compile this. I say cc, and then we have to create a different executable file for this. So I say -o, which stands for output, and this is a reader process. So I'll say reader.out. So you can see that the compilation is done. Now I'll compile the writer process as well. Again, I'll say -o, writer.out. Okay, that's also done. So first we have to execute the writer process. So I'll say /writer.out. Now once that is done, you can see that the next line is not displayed over here. That will be displayed only when we execute the reader process. So we have to say dot slash reader dot out. Okay, so now you can see that over here we have enter a string. So I say hello, and you can see over here that the number of vowels is 2 inside hello. So that was the first program. Now we will see the second one. I'll open the file first. Here it is. So now this is about the unnamed pipe. So unnamed pipe exists only between a parent and the child process, so that they can communicate to each other. Now if the parent or the child dies, then this pipe will not exist anymore, and this unnamed pipe will not have any entry inside the directory. So over here we have an integer array, that is FDPTR of size 2. Now the size is 2 because one value will be for reading and the second value will be for writing. So that array at 0, that is the 0th position, is for reading and the first position is for writing. Okay, so you will have 2 pointers, read pointer and write pointer. Now what I do is I created that array. Using the pipe system call, I create the unnamed pipe, and after that, using the fork system call, I create a child for that. Once the child is created, inside the child, what I'll do is I'll check if the value that is read by the parent is even or it's odd. That means the value that's read by the parent must be written into the pipe, and the child process must read whatever value you are writing into the pipe and then process it. So inside the parent, I have asked the user to enter a number, and it has scanned that particular number, and we are writing at FDPTR at 1 address of num, that's the number that was the input, and size of num. After that, I have the wait system call so that the parent does not terminate before the child completes its execution. And now what we have to do is the child has to check if the number is even or odd. So first of all, it has to read from that pipe. So using the read system call, I have read from the pipe. I have printed that number that's read, and I have said I have checked if it's even or odd. That means I have to modulus it. I have to find the remainder by dividing it by 2. If the remainder is 0, then it's even, otherwise it's odd. So that was the program. We'll execute that. That's done. I'll say dot slash a dot out. Now you can see that we are in the parent process. The parent process will ask for a number. I'll enter 5, and now you can see that it's odd. So that was very simple. I hope you understood it. Thank you.